Hey, eighth grade. So last week we started talking about space, and then we're going to continue that this week. And today we're going to go a little bit more in depth when we talk about the idea of seasons. So, quick review: the Earth moves in two major ways. There's rotation, which is spinning on its axis, and one rotation takes 24 hours. And then there's revolution, which is the movement of the Earth around the sun. One revolution takes 365 days to complete, or 1 year. The imaginary line that passes through the Earth's center and the North and South poles is called Earth's axes. Near the equator, the sunlight hits the Earth directly, so we call that direct sunlight. And near the poles, it arrives at an angle. The difference in direct and indirect sunlight leads to the really drastic differences in temperature from place to place. So you'll notice that on June 21st, the direct sunlight, due to the tilt, is hitting a little bit higher than the equator, and then the indirect is coming in both at both poles. So this creates indirect versus direct sunlight. But as the Earth rotates, this indirect and direct sunlight can shift to other areas of the Earth. If the Earth's axes were straight up and down, relative to its orbit, temperatures in an area would remain fairly constant throughout the year, and there would be no such thing as seasons. So, Earth has seasons because its axis is tilted as it revolves around the sun. So, last week we talked about revolutions being the reason for the seasons, but the axis also has a big role in that, in the way it is tilted. So throughout the year, there's two things called the solstice, and this is when the sun appears to the farthest north, or the equator once each year, and the farthest south once each year. These days are known as a solstice. When the sun appears the farthest north, it's the summer solstice in the northern hemisphere, and the winter solstice in the southern hemisphere. And this is the longest day in the northern and the shortest day in the southern. And it occurs around the 21st each year. So basically, the opposite is happening in each hemisphere. So on June 21st, the northern hemisphere has its summer solstice, and it's the longest day of the year. And on June 21st, the southern hemisphere has its winter solstice, and it's the shortest day of the year. On the 21st of December, this is actually reversed, and it becomes the shortest day in the northern hemisphere, and it's their winter solstice, and the longest day in the southern hemisphere, which is the summer solstice. So on June 21st and December 21st, we have these two solstices, and the what's actually happening at each hemisphere is different. So if you were to look at this, you'll see that in the summer solstice for June 21st, the northern hemisphere is having the summer solstice. This is where the most light is coming in. As opposed to December 21st, the southern hemisphere is having their summer solstice while the northern is having their winter solstice. So these are always opposite, and the length of the day is also opposite. Halfway between the solstices, neither hemisphere is tilted towards the sun, and these days are known as the equinox, and we call equinox stands for equal night. So day and night are each about 12 hours, and the spring equinox occurs around the 21st in the northern, and the autumnal equinox occurs around the September 22nd in the northern hemisphere. And we are in the northern hemisphere, so this would be true for New Orleans and Louisiana. So the spring equinox is the March 21st, and the autumnal equinox is September 22nd. Once again, these would be reversed towards for the southern hemisphere. So if you look at this, we have March 20th and September 22nd. And this kind of shows you a side view, if it were straight up and down, and where that direct and indirect sunlight is coming in. So this image is to show you both the spring and the autumnal. Sometimes the spring is called the vernal equinox and the solstices, and it tells you where the energy is the greatest coming in. So if you'll notice that the vernal, the incoming solar energy is actually equal in both hemispheres, and that's true for the spring and for the autumnal. And then for the summer solstice, the incoming solar energy is greatest in the northern hemisphere, which is why the northern hemisphere would have their summer solstice. And in the December 21st, the northern hemisphere would be having their winter solstice because the energy coming in is greatest in the southern hemisphere. And this is another depiction of that, but this one also tells you about the days and the nights. So from the summer to the autumnal solstice and equinox, the days are longer than the nights and the nights are lengthening. And then once you go past the autumnal, the nights are longer than the days and it continues to lengthen. After the winter solstice, the nights are longer than the days. And then from the vernal into the summer, the days are longer than the nights. Go ahead and move on to your practice for today. And once you've completed that, you may work on your challenge page, your exit ticket, and Quizlet.